Exercise 4.3, question number 21. Show that integration of x raised to power n arc tangent x. Arc tangent x is tangent inverse of x. Dx is this thing, and hence evaluate x cube tangent inverse of x dx. First we have to show that this one is equals to this thing, and then we have to evaluate this integral using this formula. First, consider this integration. Since tangent inverse of x has no integration, so consider it as the first function, and the rest of the function will be considered as the second function. First function a will come as it is into integration of second function, power plus 1 divided by that power, minus integral derivative of first function is 1 over 1 plus x square into integration of second function, that is the same answer. Now it will be x raised to power n plus 1 over n plus 1 tangent inverse of x minus, this is constant, it will be taken outside like this, minus 1 over n plus 1 integration x raised to power n plus 1 over 1 plus x square dx. You see, this is the same formula. So hence we just showed it that this integration is equals to right hand side like this. Now name it as the first equation. We need to evaluate x cube tangent inverse of x. Now here you see we have x raised to power n and we have here x cube. So if we just put in place of n equals to 3, then we can easily use this formula and can easily evaluate this integration. So just in equation 1, put n is equals to 3. So in place of this equation 1, put n is equals to 3, we'll get x cube tangent inverse of x dx equals x 3 plus 1 over 3 plus 1 tangent inverse of x minus 1 over 3 plus 1, then integration x raised to power 3 plus 1 over 1 plus x square like this. Just simplify the powers, we get x4 over 4 tangent inverse of x minus 1 over 4 integration of x raised to power 4 over 1 plus x square. I already told you that if you have the numerator power greater than the denominator power, then this is an improper fraction and we need to solve it to convert it into the proper fraction by dividing it. Now how we are going to divide it? We have x raised to power 4 over 1 plus x square. Just write x raised to power 4, highest numerator will be written inside and 1 plus x square will be written outside like this. Divide it. Consider this x power 4 and divide it with x square. We will get x square. So just write x square here. And now this x square will be multiplied with this whole thing. We will get x raised to power 4 plus x square if we multiply it with both. Now change the signs. For the subtraction we need to change the signs. This will be cancelled. We will get minus x square. Now here we get minus x square. Take this as a numerator and divide it with this x square again. We will get minus 1 now. So just write minus 1 here and now multiply minus 1 with this whole again. We will get minus 1 minus x square. Just change the signs to subtract. This will be cancelled. We will get 1. Now we need to write it in fraction form. The method for writing it in fraction form is in this direction. Move in this direction. So first write x square minus 1. Then what is the sign with this number? This is plus. This is 1 over this 1 plus x square. So it can be written like this. So after dividing, I got x square minus 1 plus 1 over 1 plus x square like this. Now integration can be easily split in these 3 parts. Just split it into 3 parts. Also consider this coefficient with them as well. We will get these 3 integrals. Minus 1 over 4 x square will give us minus 1 over 4 x cube by 3. Here integration of dx is x and integration of 1 over 1 plus x square is tangent inverse of x. I have taken 1 by 4 as common and the rest of things will come as it is. Plus constant of integration should be written at the end of the solution. 22 says, find a reduction formula. You see, in the previous question, this formula was a reduction formula. But now in question number 22, we need to find first the reduction formula, and then we will use that reduction formula to evaluate this integral. But in the previous question, we were given with the direct reduction formula. Now the need is to evaluate here. So just write this integral x raised to power n e raised to power x dx. We know that this can be reduced by taking differentiation. So just write as first function and this e raised to power x as the second function. Now integration of parts will give us first function into integration of second function minus integral derivative of first function power down power minus 1 into integration of second function. This a is a constant, it will be taken outside, n also, so it will be n over a integration x raised to power n minus 1 e raised to power x. Here we have 3. We have 3 here. We will just reduce this formula up till n minus 2. Just 1 unit back from 3. Okay. Now take x raised to power n minus 1 as first and this one as second, and again just different integration by parts. First function will come as this, integration of second function minus integral derivative of first function power down power minus 1 into integration of second. Open this whole bracket. This will become minus n, a into a will be a square, x raised to power n minus 1 e raised to power ax, minus minus plus n over a. This when multiplied with this a will become a square. This constant will also come outside. It will be n minus 1. We will left behind x raised to power n minus 2 e raised to power ax dx. Just stop here now. Because we have x cube, so we can reduce it up to n minus 2. Just 1 unit back to 3. Name it as the first equation. Now put in this whole reduction formula n equals to 3 because we need x cube. So to make it x cube, put n is equals to 3. So just replace n with 3 wherever n is. X cube over a e raised to power ax. Then here n 3, 3 minus 1, then 3 minus 2 in this thing. Now this is x e raised to power ax dx. Integration by parts will give us this thing that we repeatedly have done it before many times. So do it as the integration by parts formula. Just open this whole bracket, we'll get this thing. Now integration of e raised to power ax is simple. That is e raised to power ax over a. That a when multiplied with a cube will become a4. I have taken the highest denominator as common and e raised to power ax with it as well. So I will left behind a cube x cube minus 3a square x square plus 6ax minus 6 plus constant of integration. Question number 23. In question number 23, we need to find out the reduction formula for sine nx dx and integration of cos nx dx. First, I will find the reduction formula for this integral. Let's suppose this is equals to I subscript n equals sine nx dx. I can write this n as n minus 1 plus 1. Now you know that using the power rule or the exponent rule, it can be split into two parts. I will get sine n minus 1x and sine 1x, that is sine x. Let sine n minus 1x as first function and this as second function because we can take any of them as first and second, but it will be easier if we consider it as first function. Now using the integration by parts, first function will come as this into integration of second function will this minus derivative of first function is power down power minus 1 and without power derivative is cos x, and the integration of second function is this thing. Now it will become minus cos of x sine n minus 1x. This is a constant term, it will be taken outside. Minus minus will become plus n minus 1. Cos x is cos square of x sine n minus 2 of x. I can write in place of cos square of x as 1 minus sine square of x because I want to convert this whole equation in sine. So using the identity cos square of x plus sine square of x equals to 1, I can get the value of cos square of x here as 1 minus sine square of x. Now this thing can be multiplied with 1 and also with this and separate the integration. it will become sine n minus 2x dx minus this thing, this minus minus, sine square of x when multiplied with sine n minus 2 of x. It will become sine n minus 2 plus 2 and x. This is sine n of x. This is the same thing as we let in. So just replace it with in. Here we have n minus 2, so just replace it with n minus 2. Now left hand side and right hand side have the same in. Move it to the left. We will get this thing. Now take in as common. We'll get 1 plus n minus 1. This is cancelled. We'll get n. So this n is multiplied with in. So just divide it with other side. So we'll get this general reduction formula for integration of sine nx dx. Now we need to find out the reduction formula for cos and integration of cos nx dx. The same thing we will do it here, the same like we did in this integration of sine nx. Let it equals to in, split it into two parts, like we can write as n minus 1 plus 1, just as split it into two parts. Consider cos of n minus 1 of x as 1 and this as second function. First function as it is into integration of second function minus integral derivative of first function into integration of second function dx. Now simplify, open is all the terms. Now I am converting this whole thing into cos function. So just replace sine square of x as 1 minus cos square of x and multiply it inside this thing. We'll get these two integrals. We know that this is the same integral, so let it in, and this is cos n minus 2, so let it in minus 2, which is the same thing as like this. Move it on the left side. It will be in plus n minus 1 in. Don't get confused with these n's. This is a subscript representation. Okay, this will be cancelled and this n is multiplied with in. So just divide it on the other side like this. So we got the reduction formula for integration of cos nx dx. Question number 24. Find a reduction formula for integration of xn sin x dx and then use this reduction formula to evaluate this integral. Now here in place of n we have 4. So we just reduce it up to n minus 3. Now take xn as first function and sin ax as second function dx. How we take first and second, this is already explained to you in the first, second parts of the exercise 4.3. So you can consult for the first part or for the second part for this, choosing the integration by parts functions numbering. Now using the formula, first function will come as this into integration of second function minus integral derivative first into integration of second. Just simplify it, minus minus will become plus, n over a will be taken outside. We will have cos ax x raised to power n minus 1. Whatever you have considered here first and second, the same consideration will be taken here. This polynomial function will be taken as first and this one as second. Again use the integration by parts formula. First function as it is into integration of second minus integral derivative of first power down power minus 1 into integration of second function dx. Now open this whole bracket. It will be n a into a square x raised to power n minus 1 sin ax minus n into n minus 1. A into a will be a square and integration x n minus 2 sin ax. Again choose first and second function and again integrate it by parts like this. Open the brackets, you will get the general formula as minus x raised to power n over a cos ax plus n x raised to power n minus 1 over a square sin ax plus n into n minus 1 x raised to power n minus 2 over x a cube cos ax minus n into n minus 1 n minus 2 over a cube integration of x raised to power n minus 3 cos ax dx. Now let this equation equals to equation number 1. Now we need here in place of n we need 4. So we have to replace in this equation 1 n equals to 4. Now here we have a but here we have 4. So just replace in equation 1 a equals to 4 as well. So just replace n equals to 4 and a equals to 4 in equation 1. we will get x raised to power 4 sine 4x dx, x raised to power 4 over 4 because a is also 4, cos 4x plus 4 over 4 square will give us 16. 4 minus 1 will give us x cube sine 4x plus n is 4. 4 minus 1 will be 3. 4 minus 2 will be x square and 4 cube is 64 cos 4x like this. Also replace the values here as well like this. Now simplify the terms that can be simplified easily like this. These are cancelling with some value. These can be cancelled here. Not with the whole of, they will get 8 here, we'll get 16 here, we'll get 4 here like this. Now we get x cos 4x. It can be integrated by parts. That will give us this bracket. First function as it is into integration of second minus integral derivative of first into integration of second dx. Open this whole thing, bracket, multiply minus 3 by 8 inside, we'll get this thing, and this integration can be easily solved as minus cos 4x over 4. So after taking the highest denominator as common, because 4 when multiplied with 32 will give us 128, we'll get this answer plus constant of integration. I hope you are getting these questions. These questions are relatively tough and different from the previous questions of this exercise 4.3. Let's move to question number 25. Find a reduction formula for integration x raised to power m ln x raised to power n dx, and then use this formula to evaluate x cube ln x whole square. Now here we have m. We will just reduce it up to, we can reduce it, or you can see here we have 2 and here we have n. So we can reduce it up to n minus 1. Just 1 unit back. X raised to power m and ln x raised to power n, you know that ln x has no integration, so consider it as first and this one as second function. First function will come as it is into integration of second minus integral derivative of first power down power minus 1 and without power derivative into integration of second function. This is the same thing. Now this n and m plus 1 is constant, take it outside, we'll get this reduction formula for this integral. Now we need in place of m 3 and in place of n 2. So just replace, put n is equals to 2 and m is equals to 3 in this equation and we will get this whole equation. It will be x4 over 4 ln x whole square minus 2 by 4 x cube ln x. Now ln x has no integration, consider it as first and this one as second function. First function will come as it is, integration of second function, power plus 1 divided by that power, minus integral, derivative of first function into integration of second function. This will be cancelled and here we'll get x cube. Just open this bracket and multiply minus 1 by 2 inside like this. It will minus x4 by 8 ln x plus 1 by 8 integration x cube. Integration of x cube is x4 by 4. 4 8s are, it will become 32. So I have taken x4 and 1 over 32 as common. I will get 8 ln of x whole square minus 4 ln of x plus 1 plus constant of integration.